Can't see my screen yet. Okay, so you guys can see my screen now, right? Someone confirm that quickly. You can see my screen, right? Okay, good. So this is the paper that we are doing today. Can I raise of hands from those of you who have attempted this paper already? How many of you have attempted this paper? Okay. All right. So as you have S1 exam approaching, please make sure that you have attempted. So the bare minimum is that you should have attempted all variants from the last 2 years at least. So 2025 March, and then all 2024 papers, all 2023 papers. You should have attempted all of them. You should have attempted all of them. That's important. Okay. That's the bare minimum. But ideally, you should have attempted the last 5 years, 2020 onward, all papers. 2020 onward, all papers. That's the ideal scenario. But for that, you should have started much earlier. I hope many of you have done that. So that makes it around 5 into 7, 35, and then 1 March, around 36 papers in total from 2020 onward. But if you are late for that, then the bare minimum that you have to do is 2023 onward. That makes just around 15 papers, at least that much you should have done before the exam, right? These 15 papers, at least that's the bare minimum. That's going to be very important for you to do well in the exam. And apart from that, make sure that you're revising everything. Of course, we'll do that revision workshop this weekend as well. That's tomorrow, in fact. We'll have that tomorrow, inshallah, to revise everything. But practice is also very important. Okay, so let's get started with this. This is May-June 2023, paper 5-2. We are doing this whole paper today, inshallah. Okay, let's get started. Okay, so it says, first of all, in question number 1, the random variable x takes the values -2, 2, and 3. It's given that probability of x being equal to x is equal to k into x squared minus 1, where k is a constant. Draw up the probability distribution table for x, giving the probabilities as numerical fractions. Numerical fractions means you don't have to write the probabilities in terms of k. They have to be as numerical fractions. It should be numbers. Okay, it should be numbers, not just fractions, not just expressions in terms of k. That's what they're saying. Okay, now how do we do this? First of all, let's find out the probabilities of these possible values. What's the probability of getting x equals -2? Let's just input in the formula and see what that gives you. K into -2 whole squared minus 1. What does that simplify to? 4 minus 1, that is 3. 3 times k. That's the probability of x being equal to -2. Probability of x being equal to 2, what's that? That's k into 2 squared minus 1. What's that? That's also 3 times k. And then probability of x equals 3. What's that? That's k into 3 squared minus 1. That is 8 times k. Now, can we find the value of k from this? The sum of all of these probabilities has to be 1, right? So 3k plus 3k plus 8k is supposed to be 1. So the value of k that we get from this is 1/14. Now we can make a table that looks like this. Make a table for this, the probability distribution table. You can say you've got x and then the probability of x. There are three possible values of x, which are -2, 2, and 3. What are their probabilities? 3 into k, that's 3 over 14. 3 over 14, and then 8 over 14. This is what the probability distribution table looks like. That's what you wanted to do in this part. Make sense? Let's move on. Let's move on to the next one. The next part, it says find the expected value and variance. That's fairly straightforward. All you have to do is just add a couple of rows to the data. You can add another row that says x times p. What would that be? -2 into 3 over 14. That's going to be -6 over 14, and then 6 over 14, and 24 over 14. Add them up all together. You'll get sigma xp from that. You can see what that turns out to be. Add another row, that's x squared times p. That's 4 into this. That's 12 over 14. And then 12 over 14. And what about this? 9 into 8, that's 72, right? 72 over 14. You can find sigma x square p from this as well. See what that turns out to be. Do we have these values? Can anyone give me these values? What do you get from each of these? xp and x square p. We can find expected value and variance from this, right? Expected value of x is given by sigma xp, and variance of x, that is given by sigma x square p minus the expected value of x whole squared. Both of these formulas are given in the formula sheet under discrete random variables. Does anyone have these results? Expected value and variance. 12 over 7. Okay, so this is 12 over 7. So that means expected value is 12 over 7. We can input that here now. Sigma x square p. What about that? Sigma x square p. Okay, so in another room, I actually have a lot of kids who are playing. Do you hear a lot of noise in the background? Is it causing any problems? Can you let me know about that? Can you hear me clearly? Is that noise distracting? So I have some kids playing in the next room. It's okay. Okay, all right. So variance of x, what's that? Variance of x. All right, good. Sigma x square p. You were saying sigma x square p turns out to be 192 over 49. Okay. So this is 192 over 49. So this becomes 192 over 49 minus square of the expected value, that's 12 over 7 whole squared, and you get the value of variance from that. You can see what that is. 48 over 7. Or is that just simplification of this? Okay, I'm sorry. So you basically told me that this is 48 over 7. Okay, so this is 48 over 7. And then the variance is 192 over 49. Is that correct? 192 over 49. Okay, so that's the final answer that we get. That's it. We can just leave it like this. You can write fraction, you can write decimals if you want, or just leave it like this. Both are fine. That's your final result. Okay, let's move on. Question number 2. A sports event is taking place for 4 days, beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability that it will rain is 0.7 if it rained on the previous day, and 0.2 if it did not rain on the previous day. Find the probability that it does not rain on any of the 4 days of the event. Okay, so it does not rain on any of the 4 days. How do you think about this? So the event starts on Sunday. What do we know about Sunday? Probability of raining on Sunday is 0.4. What about probability of not raining on Sunday? That will be 0.6. That's for Sunday. Then on Monday, Tuesday, Wednesday, what can you say about those days? The probability that it will rain is 0.7 if it rained on the previous day. And it would be 0.2 if it did not rain on the previous day. So if it did not rain on Sunday, the probability of not raining on Monday, what would that be? That would be 0.8. And then the next day as well, it will be 0.8. And then the next day as well, it will be 0.8. And that will give you the result. You can see what that is. What about this now? Point 3072. Okay. 0.3072. I'm assuming it's an exact answer. If it's an exact answer, you leave it like this. You do not have to round this off. Just leave it as 0.3072. Okay. Do not round this off. Or you can write fraction as well. That's also okay. Find the probability that the first day on which it rains during the event is Tuesday. First day on which it rains. First day on which it rains. We're talking about first success. Can we say this is geometric distribution? Can we say it's geometric distribution? Can we say that? That it is geometric distribution? We're talking about first success. That's what we do in geometric distribution generally. We talk about first success, right? This is not geometric distribution because it does not satisfy the other conditions. It does not satisfy the other conditions. The conditions are that the probability should remain constant. The probability should remain constant throughout. Probability of success should remain the same. Probability of failure should remain the same. That should not change. In this case, probability of raining depends on what happened the previous day. So probabilities are not independent. They can change. So this is not geometric distribution. So we cannot use the geometric distribution formulas in this. They will not work. Okay. So what do we do then? We think of a tree diagram. They're saying the first day on which it rains during the event is Tuesday. Find the probability for that. How can we do that? Let's make a tree diagram until Tuesday at least. So what are the possibilities? On Sunday, it could either rain or not rain. Then next day, if it rained the previous day, it could either rain or not rain. And Tuesday then, again, rain, no rain, rain, no rain. So for those first three days, that's what the tree diagram would look like. Okay. Now in this tree diagram, on the first day, what are the probabilities? What are the probabilities on the first day? Probability of raining on Sunday, what was that? That was 0.4. Probability of not raining, that's 0.6. If it rained on Sunday, if it did rain on Sunday, then what about probability of raining the next day? If it rained the previous day, the probability of raining the next day is 0.7. So this would be 0.7. Okay. And this would be 0.3. And in fact, in this case, we don't even need that. We can actually do it without the tree diagram as well. We can do it without that. We don't need the tree diagram because if the first day on which it rains is Tuesday, we could actually just do it directly as well. So we actually don't need that. We don't need the tree diagram yet. We might need that for the next part if there's any. Okay, we'll think about that. But in this case, we could do it without that as well. Because it's only one path on the diagram, and that is this path. No rain, and then rain. That's the only path that we care about. If you want, you can do it directly as well. So the way to do that would be you say Sunday, Monday, Tuesday. If Tuesday is the first day on which it rains, that means on Sunday it should not have rained. That's 0.6. On Monday, it should also not have rained. That's 0.8. And then on Tuesday, it should have rained. That's 0.2. And that would give you the result for this. So in this case, we could do this without the tree diagram as well. So it works without that. You can see what this turns out to be, 0.6 into 0.8 into 0.2. What's this? 0.096? Okay, so this is 0.096. So we could just do it directly like this. It's only one path. We know exactly what path to follow. So follow for this. No rain, and then rain. Okay, these are the probabilities that we've got. In the next one, it says, find the probability that it rains on exactly one of the 4 days of the event. Exactly one of the 4 days of the event. Now for this, if you want, you could make this tree diagram, but that will become very big. You'll have like, now we're talking about 4 days. You have to extend it further. So that will become 16 branches in the last step. Let's do it without the tree as well. Just think of it logically. If we want exactly one day on which it rains, what are the possibilities? Let's write that down. We've got Sunday, Monday, Tuesday, and Wednesday. If it only rains on one day, we could say it rains on Sunday. It rains on Sunday, does not rain on Monday, does not rain on Tuesday, does not rain on Wednesday. That's one possible case. Another possible case would be it rains on Monday and not on the other days. Another possible case would be it rains on Tuesday and not on the other days. And another possible case would be it rains on Wednesday and not on the other days. Now, exactly one day out of the 4 days. Probability of it raining on Sunday, what was that? That was 0.4. So this is 0.4. And then if it rained on Sunday, what's the probability of it not raining on the next day? Let me write that down. If it rained on one day, the next day, the probabilities are 0.7 and 0.3. Okay. If it did not rain on one day, the next day, the probabilities are, probability of raining is just 0.2. So the next probability would be 0.2 and 0.8. Okay, let's just refer to this now. So if it rained on Sunday, that means the next day, the probability of not raining is 0.3. So we have 0.3 here. And then if it did not rain on Monday, the next day, the probability of not raining is 0.8. So that becomes 0.8. And then again, 0.8. This is your first case. The second case is it did not rain on Sunday. The probability of not raining on Sunday is 0.6. If it did not rain on Sunday, that's this case here. What's the probability of it raining on the next day? That's 0.2. Now make sure that you're focusing, because repeating this whole thing would be difficult. So if you have any question, you can ask right now. So 0.6, the probability of not raining on Sunday. If it did not rain on Sunday, we are here. Probability of raining the next day, what's that? That's 0.2. So now it rained on Monday. What's the probability of it not raining the next day? 0.3. So it did not rain this day. Now the next day, the probability is 0.8. This is 0.8 now. Okay, it's quite confusing because of the different probabilities that we've got there. Again, probability of it not raining on Sunday. Probability of it not raining on Sunday, that's 0.6. If it did not rain on Sunday, the next day as well, the probability of not raining is 0.8. Multiply by 0.8. Now the next day it has to rain. So if it did not rain the previous day, probability of it raining the next day, that's 0.2. And now it has rained on Tuesday. So next day probability of not raining is 0.3. This is what we get. Okay. Then the last case, it did not rain on Sunday. It did not rain on next day. It did not rain on next day, 0.8 again. And now it rained, that's 0.2. These are the 4 possible cases that you have. A lot of thinking for these 3 marks. But now, let me just check these quickly. 0.4, and then it rained that day. So next day, 0.3, and then 0.8, 0.8. That makes sense. 0.6, then 0.2, and then 0.3 and 0.8 makes sense. 0.6, 0.8. And then it did not rain that day. So next day raining, 0.2, and then 0.3. Yeah. So these are the 4 cases that we're getting. Find each of them, and you say it's either this first case or the second case or the third case or the fourth case. You add all of them up, and that will give the total result. Okay. So what do we get from each of these? 0.4 into 0.3 into 0.8 into 0.8. That's the first case. That is 0.0768. Okay, next we have 0.6, 0.2, 0.3, and 0.8. That is 0.0288. Next we have 0.6 into 0.8 into 0.2 into 0.3. That is again the same thing because we had the same numbers, 0.6, 0.8, 0.3. Okay, 0.0288. And then the last one, 0.6 into 0.8 into 0.8 into 0.2. You add all of these up, and that will give the total result. This is the same as the first one. Why is it the same as the first one? 2 into 6, 4 into 3. Okay, all right. 0.0768. Add all of these up, and you get the final result. What's the final result that we get? 0.2112. 0.2112, and that's the final answer. Thank you. Okay. Make sense to everyone? Okay, not that complicated, but you have to be very focused while you did this because of the different cases involved. Okay, I'll be back in a couple of minutes, and not a couple of minutes, a few seconds. Just give me. Okay, I'm sorry. I think my son was here. He did something while he was here. He was telling me he spoke to you guys in his own language. Okay, let's look at the next question. Yeah, I'm sorry about that. He just told me about it. मैं बाहर जाके बाकी बच्चों को चुप करा रहा था. So he came here inside. Okay. Okay, question number 3. Let's have a look at this. The following back-to-back stem-and-leaf diagram represents the monthly salaries in dollars of 27 employees at each of 2 companies, A and B. We've got the stem-and-leaf diagram. Find the median and the interquartile range of the monthly salaries of employees in company A. Okay, median and interquartile range. How do we find this? For company A, remember it's ungrouped data. This is ungrouped data, right? So for ungrouped data, how do you find median and interquartile range? For median, we use n plus 1 over 2, right? What's the total number of values? That's 27. 27 plus 1 over 2, that gives us 14. The 14th value is going to be the median. What's the 14th value? It's counted like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the 14th value, and that's your median. Okay. Now let's look at the key. It says 2, 7 with 1 here. That represents 2710 for company A. So what does this number mean then? It's the same number, 271. So we can write this as 2710. That's the median. Okay. That's the first thing that you have to do in this case. Then they want us to find the interquartile range. For interquartile range, please remember the formulas do not work. You cannot use any formulas n over 3, n over 4, 3n over 4, or even n plus 1 over 4, or 3n plus 1 over 4. Those formulas are not reliable. They sometimes work, at other times they would not work. Okay, so you cannot rely on them. You have to use this method. The median divides your data into two parts. One part is on one side of the median, this part, and the other part is on the other side of the median, that's this part. Find the medians of these two parts of the data. Median of the yellow part. How many values do we have in the yellow part? We've got 13 values, right? 27 were the total values. We've got one median, so that's 26. 13 values on one side, 13 on the other side. So 13 plus 1 over 2, what does that give you? 7th. In each of these parts, the 7th value is going to be the quartile, upper quartile or lower quartile. 7th value, 1, 2, 3, 4, 5, 6, 7. This is the 7th value on one side. We would say that's the lower quartile. That's 2610. And then 7th value in the green part, 1, 2, 3, 4, 5, 6, 7. That's this value. That's 2840. That's the upper quartile. So what's the interquartile range going to be now? 2840 minus 2610. In the final result, you should always write units. In representation of data topic, always write units in any diagrams, in any calculations that you're making. Always write units there as well. What's this? This is 230. That is the interquartile range that we were looking for. Make sense? Any problems with this? Any questions? No, you don't have to show any work. You don't have to show any work. You can write down, for median, you don't have to show any working. You can write down the median directly. For interquartile range, you should show the upper quartile, the lower quartile. For median, you don't have to show any work. Okay. No problems. Okay, let's look at the next part now. The lower quartile, median, and upper quartile for company B are given. We need to draw two box and whisker plots in a single diagram to represent this information for the salaries of employees at companies A and B. Okay. How do you do that? Let's make an axis here like this. This is the horizontal axis. You have to label this appropriately. What does it represent? It represents salaries. So you have to write that down clearly. Labeling is important. It represents salaries in dollars. That's the horizontal, that's the axis. And now on this diagram, choose any two lines on which you draw those box and whisker plots, this and this. Or you can choose one further away if you want. And draw those two box and whisker plots. Now, what I'll do is I'll write down the information on the side here first. We've got A and we've got B. There are 5 points that we need to be able to draw a box in Whisker plot. 5 points, 5 values. What are those 5 values? The minimum value, the lower quartile, the median, the upper quartile, and the maximum value. Now, what are the values for A? First of all, we found the lower quartile, that's 2610. Let's write that down here. Upper quartile, that was 2840. Median was 2710. In the data, the lowest value was this 2500, and the maximum value was 3010 for A. This is the data that we've got for A. For B, what's the data? The lower quartile is 2600. I would recommend that you do this part at the end of the exam. You do this part at the end of the exam. Okay. Lower quartile, what's that? The lower quartile is 2600. The upper quartile is 2780. And the upper quartile is 2780. Median is 2690. The minimum value for B, what's that? That's 2540. Maximum value, that's 3090. That's the maximum value. Okay, so these are the points that you have here. These are the points that you've got here. Let's represent these points. Okay, so choose any particular row for A and mark those points. Now you have to choose the scale appropriately first as well. The lowest value in the data that you have to represent is 2500, and the maximum value in the data that you have to represent is 3090. So you can take a scale like this. You can start from 2500, and then you have 2600, 2700, 2800, 2900, 3000, and 3100. Okay, that's what you could do on the horizontal axis. Let's mark those points now. 30 for A, let's mark the points. 2500, that's 1 point. 2610, that's another point. 2710, 2840, 3010. For B, we have 2540, 2600, 2690, 2790, 2780, and 3090. Okay, so these are the points that we've got. Now, the points on the sides, they will have straight lines like this. You've got this line here. Always draw these diagrams using a pencil, okay? So that if, in case you need to erase something, you can do that easily. In the middle, you would have a rectangle. You can choose any width for the rectangle. Let's choose 3 boxes up and 3 boxes down. It would look like this, and make a vertical line in the middle at the median. That's the first box in Whisker plot. And then for the second one, again, draw lines on the sides like this. In the middle, make a rectangle. Now, when you are making 2 diagrams, 2 box and Whisker plots on the same diagram, the widths of the rectangles that you have, they should be the same. So if you chose 6 boxes as the height from the first, in the first box and Whisker plot, in the second as well, it should be the same width. It should not be different. The gap between these boxes that does not represent anything. This distance, vertical axis, does not represent anything. So you could draw the second plot here if you wanted. It doesn't matter. You could draw that anywhere. On the vertical axis, you don't have anything, right? That's the second box in whisker plot. That's what you have to plot here. That took a lot of time. And now you have to label them appropriately. Labeling is important. Otherwise, again, you can lose marks. You'd say this is A and this is B. On the horizontal axis, you should have proper labels. This is salaries. Okay. Let's move on. Let's move on to the next part. In the next part, it says, comment on whether the mean would be a more appropriate measure than the median for comparing given the information for the two companies. Is mean a better measure or median a better measure if you want to do a comparison of both of these data sets? Look at the data. Do you see any outliers? This is an outlier in this data, right? When you have an outlier in the data, mean is not an appropriate measure. Okay, mean is not an appropriate measure. So what's going to be more appropriate? Median is going to be more appropriate. So you would say median is more appropriate. But we have to give a reason for this. What's the reason? Because of the outlier, and you have to specify that outlier. In these data, that is, what's the outlier? You have to specify that so that examiner understands that you have not just memorized the statement that median is more appropriate because there's an outlier. You have to apply that to this particular question. What's the outlier here? This number 3090, you should write that here, is an outlier 3090. Right? And that is why median is more appropriate. So when you have outliers, then mean is not an appropriate measure because mean is affected by outliers. Okay, median is more appropriate. Okay, let's move on. Now it says, question number 4, a fair 5-sided spinner has sides labeled 1, 2, 3, 4, 5. The spinner is spun repeatedly until a 2 is obtained on the side on which the spinner lands. So you're repeating something until you get a 2. That should remind you of something. Until you get first success, right? Until you get first success. That's geometric distribution if the probabilities remain constant. Okay. 5-sided spinner. We have 5 numbers. Apart from stem and leaf, you've got a cumulative frequency curve, histogram, and also box and whisker. These are the 5. These are the 4 diagrams that you've got: stem and leaf, box and whisker, cumulative frequency, and histograms. Okay. The random variable x denotes the number of spins required. Find the probability of x being equal to 4. So number of spins required to get a 2. Until you get 2, until you get your first success. So we are calling getting a 2 a success. This is what we're calling a success. So we say it's a geometric distribution. It's a geometric distribution with probability of success equal to 1 over 5, right? Or 0.2. Because it's a fair spinner, all 5 options have the same probability, that's 0.2. Probability of success is 0.2. Okay. Probability of failure, what would that be? That will be 0.8. What's the probability that x is equal to 4? That you get your first success on the 4th attempt. You get your first success on 4th attempt. Probability of x equals r, that is equal to q raised to power r minus 1 times p in geometric distribution. Just input values in that. 0.8 raised to power 4 minus 1, which is 3, times 0.2, and that will give you the result. You can see what that is. What's the value that we get from this? .1024. 0.1024. That's the first part. Now it says find the probability that x is less than 6. Now again, it's a geometric distribution. For geometric, we have a direct formula for inequalities that you need to remember. Probability of x greater than r is equal to q raised to power r. This is less than 6. That means we'll have to do 1 minus something. We can write down the numbers to understand that. 1, 2, 3, 4, 5. Less than 6 means we want these 5 numbers. What are the numbers that we do not want? 6, 7, 8, so on. These are the numbers that we do not want. So how do we subtract these numbers from 1? Using the greater than form. These numbers can be described as numbers that are greater than 5. So 1 minus probability of x greater than 5, that is 1 minus q raised to power 5, and that becomes 1 minus 0.8 raised to power 5, and that should give you the result. You can see what that is. What's this number? 1 minus 0.8 raised to power 5? 0.672. Okay. 0.672, that's the final result. That's what we were looking for. Okay. That's it. Let's look at the next one now, part C. Two fair-sided spinners. So now we're talking about two spinners. They had one spinner earlier. Now we've got two spinners, each with sides labeled 1, 2, 3, 4, 5 are spun at the same time. If the numbers obtained are equal, the score is 0. Otherwise, the score is the higher number minus the lower number. Find the probability that the score is greater than 0, given that the score is not equal to. We've got two spinners that we're spinning, and then score is calculated using some formula. When you have two events, it's often a good idea to make a 2D matrix. If that's feasible, in this case, that is feasible. We can make a 2D matrix, 2D table for this, right? On one axis, one axis, you would have the numbers from one spinner, 1, 2, 3, 4, 5. On the other axis, you have numbers from the other spinner, 1, 2, 3, 4, 5. And now you have the score written inside this table. How is score calculated? The score is 0 if the numbers are equal. So that means 1 and 1, the score is going to be 0. 0 with 2, 2 as well. 3, 3 gives 0. 4, 4 gives 0. 5, 5 gives 0. So on the diagonal, the scores are 0. Otherwise, the score is the higher number minus the lower number. So 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. So they're saying higher number minus the lower number. They could also say difference between the numbers in that case as well. We would do the same thing. We'll just subtract the smaller number from the bigger number. Okay, in that case as well, we'll do the same thing. 2 minus 1, that's 1. 3 minus 1 is 2. 3, 4. Similarly, you complete the rest of the table. 1, 2, 3, 1, 1, 2, 2, 1, 1, 3, 2, 1. These are the values that you have in the table. These are all the possible scores. Find the probability that the score is greater than 0, given that the score is not equal to 2. Okay, so what's that probability going to be? In the denominator, you have the event that is given. What is given? Score is not equal to. How many outcomes are there that in which the score is not equal to 2? So we've got 25 total outcomes. 25 total outcomes. 3 and 3. 6 of them are 2s. How many of them are not 2s? 25 minus 6, that's 19. 19 outcomes are those that are not 2s. Out of those 19 outcomes, what's the probability that the score is greater than 0? Out of those 19 outcomes, score is greater than 0. That means score is not 0 as well. So we get rid of the zeros and we get rid of the 2s and the 2s. The remaining outcomes, in all of them, the score is greater than 0, right? How many are there? 3 and 7 and 14. 14 over 19, that's what the probability turns out to be. You can write it directly. That's the final result, 14 over 19. Is that okay? Makes sense to everyone? No problems? You could also find the probability separately. Probability of the intersection where the score is not zero. So it has to write in the formula in case that helps. So the conditional probability formula, what would that be in this case? It'll be probability of the score being greater than zero, and not being equal to 2. In the denominator, you have probability of the score not being equal to 2. Okay. So not equal to 2 is 19 cases. The probability of that would be 19 over 25. Condition outcome satisfying both of these conditions, that it's greater than 0 and also not equal to 2. Probability of that would be 14 over 25. 25 is going to get cancelled out in any case. So you can just do 14 over 19. That gives you the result. That turns out to be 14 over 19. Okay. That's your final answer. I hope that makes sense. Let's go to the next one now. That was question number 4, part C. Now it says 2 spinners are spun at the same time repeatedly. Okay. For 9 randomly chosen spins of the 2 spinners, 9 randomly chosen spins of the 2 spinners. So we're just spinning the spinner 9 times. Find the probability that the score is greater than 2 on at least 3 occasions. Okay. First of all, let's focus on the score is greater than 2. Do we know what this probability is? We don't. Let's find this first of all. Find the probability that on one spin, the score is greater than 2. What's that probability? We've got this table. We can use that now. Greater than 2 score. That's these 3 cases. And these 3 cases. That's 6. That's 6 cases. So we can say this probability is 6 over 25. In decimals, that would be 6 times 4, that's 24, so 0.24. So that would be our criteria for success, right? That on one attempt, the score is greater than 2. That's our success criteria. So now we can think of as at binomial distribution. We're talking about number of successes, that we have at least 3 successes. So it's a binomial distribution. We're doing something repeatedly. And we're talking about getting probability of a certain number of successes. The total number is given. That's n, which is 9, equal to 9 in this case. We've got something repeating. The probability of success remains the same, 0.24, and the failure therefore would be 0.76. We want to find the probability that x is greater than or equal to 3. At least 3 occasions means it's greater than or equal to 3. It could be 3 or greater than that, right? How do you find this probability? This is binomial. We don't have a direct inequality formula for binomial. We have to find this individually. 3, 4, 5, 6, 7, 8, 9, that's a lot of cases. We can reverse this. We can say that's the same thing as saying 1 minus probability of x less than 3. So 1 minus probability of x equals 0, x equals 1, and x equals 2. So we remove these cases from the total probability. What's the formula? NCR, p raised to power r, q raised to power n minus r. Let's just input values in that. 9C0 into 0.24 raised to power 0 into 0.76 raised to power 9 minus 9C1 into 0.24 raised to power 1 into 0.76 raised to power 8 minus 9C2 into 0.24 raised to power 2 into 0.76 raised to power 7. Okay, now we can evaluate to see what this turns out to be. What's the result that you get from this? Anyone? We have to find x greater than or equal to 3, right? We have to find x greater than or equal to 3. Right? Greater than or equal to 3 means we want the probabilities of 3, 4, 5, 6, 7, 8, 9. If you were to find them, we would have to add all of them up. But that's a lot of calculation to make. So what we do is we say total probability is 1. We subtract from 1 the probabilities of 0, 1, and 2. We get rid of this from 1. So 1 minus all of that. Okay. So you could either write it like this, 1 minus brackets and then plus inside. If you don't use brackets, then all of them would have minus with them. Like this. Okay. You're saying that's 0.371. Thank you. That's the final result that we get. 0.371. That's the final answer. Okay, let's move on. That was part D. Let's look at the next one now. We've got normal distribution next, and then most likely permutations combinations after that. Yes. And that's it. So only 2 more questions. Okay, question number 5 now. The lengths of Western bluebirds are normally distributed, with mean 16.5 and standard deviation 0.6. A random sample of 150 of these birds is selected. How many of these 150 birds would you expect to have length between these two values? So first of all, find the probability of one bird having the length between these two values. Let's find the probability for that. We know the standard deviation, we know the mean. Probability of x being between 15.4 and 16.8. This is what we're looking for. How do you find this probability? This is simple normal distribution, right? So we first of all convert it to z. 15.4 minus the mean. The mean is 16.5 divided by the standard deviation, which is 0.6. On the other side, we would have 16.8 minus the mean, which is 16.5, divided by the standard deviation, which is 0.6. Let's calculate this and see what this turns out to be. Minus 1.1 divided by 0.6. What's that? What are the z values that we're getting? What are the z values that we're getting? Okay, let's go back to that after this question. Let's go back to that after this question first. Minus 11 over 6. Yeah, but in decimals, we have z here, right? We want value in decimals. Minus 1.833. Okay, thank you. Minus 1.83333. So in the table, we have z values correct to 3 decimal places. So we write 3 decimals here, minus 1.833. On the other side, this is just going to be 0.5. These are the two extreme values for z that we get. How do you find this probability now? Think of the normal distribution curve. This is what the curve looks like. This is what the curve looks like. In the middle, we would have 0. One value is on the negative side. That might be here, minus 1.833. The other is on the positive side. That's 0.5. Let's say that is somewhere here. We have to find the area between these two values. Area between these two values. Okay. How do you find this area? Okay. Flipping is not going to help here because in that case, this negative value will become positive, but the positive will become negative. So flipping this diagram is not going to help. We started like this. We say, this is the same thing as saying area to the left of 0.5 minus the area to the left of this. That will be the yellow region, right? We start like that first of all. So probability of z less than 0.5 minus probability of z less than minus 1.833. Now, this is the standard form, z less than a positive number. We can find this from the table directly, so that's not a problem. This is not standard, the other ones. We have to find that now. So we can think of this using a normal distribution curve as well. We've done this multiple times before. So what we have is a curve like this, let's say. And we are looking for the area on the left side here, this area, minus 1.833 to the left of this area. First of all, we can flip this. We can say that area is the same as this area on the right of the positive z value, which is 1.833. So that will be the same as probability of z greater than 1.833. But this is also not standard form. We can find this as 1 minus area to the left of this. That will be 1 minus probability of z less than 1.833. So now we can find this. This is the standard form. Now we can find this from the table. We've got probability of z less than 0.5 from there, minus this. And that will give us the result. We can see what that turns out to be. Okay. Find the probability value when z is equal to 0.5. Let's go to the table. At 0.5, let's see what probability value we get. At 0.5, we've got this 0.6915. 0.6915, subtract from this 1 minus probability of z less than 1.833. What's this? 1.833. 1.8, 3, and 3. That's what we're looking for. That's 0.9664. And then we add this to that. That's 2. That's 2, 0.9666. That's the other probability that we've got here. 0.9666. 1 minus 0.9666. Evaluate this and see what that turns out to be. What's the final result that we get from this? Anyone? 0.6581. 0.6581, that's the final result that we get. You can round this out to 3 significant figures. If you want, that will be 0.658, and that's your final answer. That's what we were looking for. Okay, that's part A. Now it says the lengths of eastern bluebirds are normally distributed with mean this. Now this is, so these are different. Earlier we had western bluebirds, now we've got eastern. So it's not related to the first part. Now these birds have a mean of 18.4 and standard deviation of sigma. It's known that 72% have lengths greater than 17.1. So we can say probability of x being greater than 17.1, where x represents the lengths. This probability is 0.72. Find the value of sigma. Now that's inverse normal. We've got the probability given. We have to find standard deviation from that. We can start like this. Probability of z greater than some value that is equal to 0.72. Now, what do we have in this place? Okay. Sorry about that. So yes, I had to reread that question. The question said, how many of these 150 birds would you expect to have length between this? We found the probability of one bird having a length between these two values, right? We found that probability. But what's the expected number of birds that you would expect to have a length between this? What's that expected number? This is just for one bird. For 150 birds, what will be the expected number of birds falling in that bracket? We would have to do 150 times 0.6581. You can see what that turns out to be. What's this number? 98.7 or 99.7? I'm getting different results. 98.7, okay. 98.7, you round this off because number of words cannot be a decimal, so that's 99, right? So the final result, it turns out to be 99. That's your final answer. Make sense? That's for one. You have to write an integer at the end. Do not leave a decimal. Generally, they accept both rounding down and rounding up. In such cases, just round this off like you normally do. 98.7, that rounds off to 99. So you write 99 there. Okay, that's your final answer. Okay, yeah, so that's one last step that you had to do in the first part as well. Now it says this probability 0.72. We can say probability of z being greater than something that is equal to 0.72. Now we have to figure out whether this z value is positive or negative. How do you do that? You can think of the normal distribution curve. Once you've done enough practice of this, you can do this without the curve as well, just thinking about this in your head. But this is what you would think about it in your head as well, as in whether z is positive or negative. So area to the right, greater than sign means we're looking at the right side. Area to the right side is supposed to be bigger than 0.5. Okay, on right side, the area should be bigger. Where do we place z? We have to place that on the negative side then. Only in that case, the area on the right side would be bigger. So z is supposed to be a negative number. So this number has to be negative here. Okay. Now that you've figured that out, this is not the standard form. We are given that this area to the right of it, all of this is 0.72. What we can do is we can flip this. We can say, okay, if the area to the right of this is 0.72, then if we were to consider the positive value of z, the area to the left of this value would also be 0.72. If you flip this, right, flip this diagram. If the area to the right of this negative value is 0.72, the area to the left of the positive value is also going to be 0.72. So we can write this as z less than the positive z value. That is equal to 0.72. And now we can go to the table, find the z value from this and see what that turns out to be. 0.72 is the probability. 0.7200, that's the probability. 7200. The immediately smaller number is this. Immediately smaller number is this. That's 0.5 and 8. But we still have to add 10 at the end, right? To make it 7200. This is 10. What's the third decimal place? 3. The z value turns out to be 0.583. Let's go back there. 0.583 is the positive z value, but we know the actual z value was supposed to be negative. So we say z is minus 0.583. That's the actual z value. Now put that in the formula. Z equals x minus mu over sigma minus 0.583 minus 0.583 minus the mean. Mean was 18.4. No. The x value was, what was the x value? Minus 0.583. That equals x, which is 17.1 minus the mean, that's 18.4 divided by sigma. You can find the value of sigma from this and see what that turns out to be. What's the standard deviation? What's the standard deviation that we get? We have to use that in the next part. So first write the more accurate number so that we can use the more accurate number in the next part then. And then you can round that off afterwards. What do we get? Anyone? All relying on each other. 17.1. 2.228. Okay, thank you. 2.2298. 2.2298. You can round this off for the final answer. That's 2.23, and that's your final answer. In the next part, it's better to use this, although it's very close to 2.23, so that might not be much of a problem. But generally, in the next part, it's better to use a more accurate number. Okay, so that's the standard deviation that we get. Now it says a random sample of 120 eastern bluebirds is chosen using approximation. Again, that means whenever you have an approximation, that means the original distribution is binomial, and you have to approximate that as normal. So we have a binomial distribution. They have chosen a sample of 120 bluebirds. That means n is equal to 120. We need to find the probability that fewer than 80 have length greater than 17.1. Probability that we have less than 80 successes. That's what we're looking for. What's the criteria for success? Length greater than 17.1. That's what we're calling success here, right? Length being greater than 17.1. Now, what's the probability of that? What's the probability of success? Greater than 17.1 length? They gave us this probability, 72%, 0.72. So probability of success in this part, that would be 0.72, and the probability of failure, therefore, would be 0.28. Let's convert it to normal now. Convert it to normal. We have to find the mean and the standard deviation. Mean, what does that turn out to be? N, which is 120 times P, which is 0.72. And standard deviation, which is 120 into 0.72 into 0.28, square root of that, and that will give us the result. You can see what that is. What's the mean? What's the standard deviation? 86.4. And the standard deviation? Just evaluate the inner part, and we'll leave it in square root form then, so that it's more accurate. 24.192. Thank you. 24.192. Now we have to do continuity correction. Fewer than 80, that means less than 80. Now use these numbers: 79, 80, 81. Is 79 included? Yes. 80? No. 81? No. So the decision changes here. Use their midpoint. X is less than 79.5. This is what you have to find out now. Using normal distribution converted to Z, first of all, Z is less than 79.5 minus 86.4 divided by standard deviation, which is square root of 24.192. Figure out what this value turns out to be. Z less than some negative value. What's that? Minus 1.4028. Okay, thank you. Minus 1.4028, that means to 3 decimal places, that would be 403. Okay, so this is the value, minus 1.403, and we want to find out this area to the left of this. Now, how do you find this area? This is not standard form. You have to flip this first of all. Flip this, and that's the same area as this one. So we can say that's the same thing as Z greater than 1.403. This is also not the standard form. So we can say this is 1 minus probability of Z being less than this value, Z less than 1.403. Now, this is the standard form. You can go to the table, find this value, 1.403. 1.403. 1.40 and 3. You have 0.9192 here. And then you've got 4 here. 92 plus 4, that will become 96. So 9196. 9196. Find this probability. We're just looking for probability, right? Yes. 1 minus this, that becomes 0.0804, and that's your final answer. Okay, that's it. That was this question. Fairly straightforward. 11 marks, 12 marks total for this question. Normal distribution is very important in terms of the number of marks that you have in the exam. It often has between 10 to 15 marks in almost every single exam. So you need to make sure that you understand this. It's a fairly straightforward question. Normally, once you understand how to do it once, then it's pretty standard question, right? It's the same working over and over again in every problem like this. And mean, is one decimal place enough here? It was only enough because it was an exact value, 86.4. Right? It was 86.4. That was an exact value. So that's why we just used 86.4. Otherwise, we should have used more accuracy there. Okay. Okay, so somebody asked about one of those previous questions. This probability of success. The success was the score being greater than 2, right? That was the criteria for success in this question. Score greater than 2. Now in this diagram, where is the score greater than 2? The total number of possible outcomes are 25. This is where score is greater than 2. That's 3 outcomes. And these are 3 outcomes where score is greater than 2. That's 6 outcomes in total. So 6 out of 25. That's the probability of success that we get here. Right? Okay, let's move on. Let's move on to the next one. And that's the last question now, permutation and combination question. Let's have a look at this. Just a reminder, we have the revision workshop tomorrow. So tomorrow we'll have the S1 revision workshop from around 4 p.m. to 10:30 p.m. So make sure that you're ready for that. Okay. Now, 4 to 10:30, I would advise you to attend as much as you can live. But if you cannot, then try to attend as much of it as is possible for you. But then you'll have the recording available right afterwards as well. But then you'll not be able to ask questions on that. That will be the problem. In live class, you would be able to ask questions after every topic as well. So that's why I think that would be a bit more beneficial. But it's your choice. But we'll start around 4 p.m. inshallah. And that will go up to around 10:30 afterwards. Okay, I'm sorry, I'm just looking for something here. Okay, that's done. And then, so that's the plan for tomorrow. Tomorrow we have that revision workshop. And then on Monday, we will be doing difficult questions from, so we're done with June today. We'll do difficult questions from 3 November papers. November 2022. Okay, so we're done with the 25 March paper. We're done with all the 2024 papers, all the 2023 papers already. You already have the recordings available from 2020 to 2022 as well. But on Monday, what we'll do is we will be doing difficult questions from November 2022 papers, all 3 variants. And then on Tuesday, it will be an open session in which you can just, ask any questions that you might have because the exam is on Wednesday. On Tuesday, it will be just an open Q&A session in which you can come up with any questions, any last minute questions that you might have from anywhere, from any past papers. If you want to do any questions from any topical worksheets from any past papers, that's what we will be doing on Tuesday, inshallah. Okay, so that's the plan until the exam now. Let's have a look at this now. Question number 6. Let's see what we do here. It says, in a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. Each person competes in only one of these sports. A team of 7 people is selected from 25 people to take part in a competition. Find the number of different ways in which this team of 7 can be selected if it consists of exactly 1 swimmer, at least 4 cyclists, and at most 2 runners. Okay, so we've got some swimmers, cyclists, and runners. 7 people have to be selected. Let's write that down here. We've got swimmers. How many of them do we have? 6. We have cyclists. There are 8 of them. And then runners, there are 11 of them. That's the total number. That's the total number for each of them. Okay, now the condition is that we want the total number to be 7. We want exactly one swimmer. Let's write down all the possible cases that we can have. Swimmer can be exactly one. It should be exactly one. At least 4 cyclists. At least 4 cyclists. So cyclist has to be at least 4. So let's choose 4 for now for the first case. And then runners can be at most 2. So one possible case can be 1, 4, and 2. That's one possible case. Okay. Then with one swimmer, the number of cyclists could be 5. And then the number of runners could be 1. That's also possible. Okay. All right. So we can have 0 runner as well, because for swimmer, they wanted exactly one swimmer. It's actually a bit confusing now. It's because do we choose one runner or not? Because in that case, we would have no person participating in that third competition. Okay, so let's read the question statement again. 25 people, 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. Okay, so the condition is only on the people that they can only compete in one sport. There's a competition. Okay, so it doesn't have to be that there has to be at least one runner. It doesn't say that anywhere. So we can have 0 runner as well. That's another possibility. So we can have 1, 6, and 0. That's the third possible case that we got. We got these 3 possible cases. We find the possible selections for each one of them, add them up together, and that will give us the result. You can see what that turns out to be. How would you do that? Out of 6 swimmers, you select 1, so that's 6C1, and 8C4, and 11C2. 6C1 and 8C5 and 11C1 and 6C1, 8C6 and 11C6, right? There was no condition in the question that said that there has to be at least one runner. So in the last case, we are basically saying there's no one participating in the running competition, and that's okay. There's no condition that there has to be someone. Okay, and that will give you something. You can see what that turns out to be. Evaluate each of them separately and then add them up together. Thank you so much for that. So we're getting 23, 100, 3696, and 168. Then you add them up, add them all together, and that will give you the final result. You can see what that is, because it's either the first case or the second case or the third case. That means you add all of those cases, and that gives you 26964. Okay, that's the first part. Pretty straightforward, a very standard question on combinations. Now it says for another competition. It's a different competition. Now a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. The team members stand in a line for a photograph. How many different arrangements are there of the 9 people? The swimmers stand together, the cyclists stand together, and the runners stand together. Again, a pretty standard arrangement case that we cover while we are covering the concepts as well. Let's do this quickly. So there are 9 people in total. The swimmers have to stand together, the cyclists have to stand together, and the runners have to stand together. We can make one box for swimmers, in which we have 2 swimmers. Remember, these are people, they're not identical. So we can say S1, S2. And then we have 3 cyclists. Let's put them in one box. C1, C2, C3. And then in the third box, we have the 4 runners, R1, R2, R3, R4. In how many ways can we arrange them? 3 boxes, they can be arranged in 3 factorial ways. The swimmers, they can be arranged with each other in 2 factorial ways. The cyclists, they can be arranged in 3 factorial ways. And the runners, they can be arranged in 4 factorial ways. And that will give you the result. You can see what that is. What do you get from this? One 1728. That's the final result that we get. That's the answer. 1728. Okay. No problems. Won't we divide for identical? What's identical here? What is identical? There's nothing identical, right? Yeah, so these are all different people, right? So we have swimmers, but these are people, right? People are not identical. These are not letters that are S, S, C, C. These are people. So they're all different. So we don't have to divide by anything for that reason. Okay, now it says, how many different arrangements are there of the 9 people if none of the cyclists stand next to each other? Okay, that's a very easy permutation combination question in this paper. I'm assuming the threshold for this paper would be quite high because normally this is the only question that's difficult. The other questions normally they're not that complicated. In this case, I think this probability question that was a bit confusing. Many people would have got this wrong, but then that's a very easy permutation combination question. So they're just saying none of the cyclists stand next to each other. All that means is we have to separate the cyclists, right? How many of them are there? There are 3 cyclists. So there are 6 other people. There are 6 other people and 3 cyclists. So let's just do it like this. We've got 3 cyclists and 6 non-cyclists. We don't care who they are. They're just not cyclists. We have to separate the cyclists. So we can use the dashes and stars method. Start with the letters that we do not have to separate. What are the letters that we do not have to separate? What are the people who we do not have to separate? The non-cyclists, make dashes for them. 1, 2, 3, 4, 5, 6. And then in the spaces in the middle, we've got the cyclists at 1, 2, 3, 4, 5, 6, 7. The cyclists can come in these gaps. Okay. In how many ways can we arrange the non-cyclists? 6 factorial ways. There are 6 places for them, and there are 6 people. That's just 6 factorial. Okay, that's a 6 factorial. And now we have 7 places, 1, 2, 3, 4, 5, 6, 7. For those cyclists, we have to arrange 3 cyclists, 7 gaps, 7 places, 3 people. In how many ways can we arrange them? 7p3. And that's it. That should give it the result. You can see what that is. 151,200. That's the final result, and that's it. That's all that we have to do here. Okay, so that's all that we have to do in this paper. 36 was the threshold. That's pretty low for this paper, I think. Let me have a look at the questions. This was quite straightforward. This one, maybe just one part that was difficult, part C, that required a lot of thinking. There were chances of careless errors. This was pretty straightforward. This was also, okay, so maybe part C and D of this, some people might have found this slightly difficult. But even with that, it's a standard normal distribution question. After that, it's a very easy permutation combination question. That's a pretty low threshold. It was a relatively easier paper. But that's it. That's it for today. And tomorrow we have that revision workshop in China. It'll be a long session, so be prepared for that. It's tiring from the experience that we had in P1 and M1. It is going to be tiring for most of you. We will have breaks in the middle. We'll have breaks in the middle, sometimes longer breaks, maybe half an hour break. But still, you will require a lot of stamina. So maybe make sure that you have good sleep before that, so that you're able to pay attention. Okay, so we'll go through the whole syllabus and the different types of questions in that session, inshallah. All right, you don't have to register for that separately. Those of you are part of the past paper sessions, as I posted in the WhatsApp group as well. Okay, you can share with others who might find this helpful as well. And see you again in the next session. Allah Hafiz.